Hello everyone, I'm Vikram P. Maduri here. I'm a software architect, and in this session, let's discuss a couple of FAQs on big data. This would be my part one video on FAQs on big data. So let's move on to various questions that most probably would come in your interview, as well as you can use this as a reference to know more about big data as well. What is big data? Big data is defined as the voluminous amount of structured, unstructured, or semi-structured data that has huge potential for mining but is so large that it cannot be processed using traditional database systems or data warehousing systems as well. Big data is characterized by its huge velocity, volume, and variety that requires cost-effective and innovative methods for information processing to draw meaningful business insights. More than the volume of the data, it is the nature of the data that defines whether it is considered as big data or not. So basically, in short, a big data is huge amount of data that cannot be processed by our traditional data warehousing systems. What do the 4 V's of big data denote? IBM has nice, simple explanation for the 4 critical features of big data: volume, scale of data, velocity, analysis of streaming data, variety, different forms of data, veracity, uncertainty of data. Here is an explanatory video on the 4 views of big data, which I'm going to present to you after this video. I'm going to share it in another video, the explanation of this 4 V's and the complexity of it and how do we approach that. How big data analysis helps business increase their revenue? Give examples. So big data analysis is helping businesses differentiate themselves. For example, Walmart, the world's largest retailer in 2014 in terms of revenue, is using big data analytics to increase its sale through better predictive analytics, providing customized recommendations and launching new products based on customer preferences and needs. Walmart observed a significant 10% to 15% of increase in online sales for about $1 billion in incremental revenue. There are many more companies like Facebook, Twitter, LinkedIn, Pandora, JP Morgan Chase, Bank of America, etc. using big data analytics to boost their revenue. Here is an interesting video that explains, I'll be again sharing this video again regarding the significant changes that we have in the companies that they have implemented big data and adopted big data concepts. So name some companies that use Hadoop. Yahoo, one of the biggest users, and more than 80% of the code contributed to Hadoop. And Facebook, Netflix, Amazon, Adobe, eBay, Hulu, Spotify, Ruby Cloud, Twitter. Differentiate between structured and unstructured data. Data which can be stored in traditional database systems in the form of rows and columns. For example, the online purchase transactions can be referred to as structured data. Data which can be stored only partially in the traditional database systems, for example, data in XML records, can be referred to as semi-structured data. Unorganized and raw data that cannot be categorized as semi-structured data or structured data is referred to as unstructured data. So we have structured data, semi-structured data, and unstructured data. So Facebook updates, tweets on Twitter, reviews, web blogs, etc. are all examples of unstructured data. On what concept the Hadoop framework works? Hadoop framework works on the following 2 core components. HDFS is the Java-based file system for scalable and reliable storage of large datasets. Data in HDFS is stored in the form of blocks and it operates on the master-slave architecture. Hadoop MapReduce. This is a Java-based programming pattern of Hadoop framework that provides scalability across various Hadoop clusters, distributes the workload into various tasks that can run in parallel. So Hadoop jobs perform two separate tasks job. The map job breaks down the data sets into key value pairs or tuples. This is the job of the map job. So they reduce the job, then takes the output of the map job and combines the data tuples into smaller set of tuples. The reduced job is always performed after the map job is executed. So and we are going to discuss about that in another session as well regarding the map jobs. Okay, what are the main components of a Hadoop application? Hadoop applications have wide range of technologies that provide great advantage in solving complex business problems. Core components of a Hadoop applications are Hadoop Common, HDFS, Hadoop MapReduce, and Yarn. So these form the main components of the Hadoop application. Hadoop Common, HDFS, Hadoop MapReduce, and Yarn. So data access components are Pig and Hive. The PIG and Hive. Data storage components is HBase. Data integration components are APAC, Flume, Scoop, Chukwa. Data management and monitoring components are Ambari, Uzi, and Zookeeper. Data serialization components are Thrift and Avro. Data intelligence components are APAC, Mahout, and Drill. What is Hadoop Streaming? Hadoop distribution has a generic application programming interface for writing map and reduce jobs in any desired programming language like Python, Perl, Ruby, etc. This is referred to as Hadoop Streaming. Users can create and run jobs with any kind of shell scripting or executable as the mapper or reducers. What is the best hardware configuration to run Hadoop? The best configuration for executing Hadoop jobs is dual core machines or dual processors with 4 GB or 8 GB RAM that use ECC memory. Hadoop highly benefits from using ECC memory. Throughout it is not low end. ECC memory is recommended for running Hadoop because most of the Hadoop users have experienced various checksum errors by using non-ECC memory. However, the hardware configuration also depends on the workflow requirements and can change accordingly. What are the most commonly defined input formats in Hadoop? The most common input formats defined in Hadoop are the text input format. This is the default input format defined in Hadoop. Key value input format. This input format is used for plain text files wherein the files are broken down into lines. Sequence file input format. This input format is used for reading files in sequence. What are the steps involved in deploying a big data solution? We have data ingestion. The foremost step in deploying big data solutions is to extract data from different sources, which could be an enterprise resource planning system like SAP, any CRM like Salesforce or Siebel, RDBMS like MySQL or Oracle, or could be the log files, flat files, documents, images, social media feeds, etc. So this data needs to be sorted in HDFS. So data can either be ingested through the batch jobs that run every 15 minutes, once every night, and so on, or through streaming in real time from 100 microseconds to 120 seconds. Data storage, the subsequent step after ingesting the data, is to store it either in HDFS or NoSQL database like HBase. So HBase storage works well for random read-write access, whereas HDFS is optimized for sequential access. So we'll go for HDFS for the sequential access and HBase for read and write access. Data processing, the ultimate step is to process the data using one of the processing frameworks like a map, reduce, spark, pig, hive, etc. Now, how will you choose various file formats for storing and processing data using Apache Hadoop? So the decision to choose a particular file format is based on the following factors: schema evolution to add, alter, and rename fields, usage pattern like accessing 5 columns out of 50 columns versus accessing most of the columns, and splittability to be processed in parallel, read and write transfer performance versus block compression savings, storage extra space extra, file formats that can be used with Hadoop, the CSV, JSON, columnar, sequence files, Avro, and pathwide files as well. The CSV files are an ideal fit for exchanging data between Hadoop and external systems. It is advisable not to use header and footer lines when using CSV files. So JSON files, every JSON file has its own record. JSON stores both data and schema together in a record and also enables complete schema evolution and splittability. However, JSON files do not support block level compression. Avro files, this kind of file format is best suited for long-term storage with schema. Avro files store metadata with data and also let you specify independent schema for reading the files. Pathwide files, the columnar file format that supports block level compression and is optimized for query performance as it allows selection of 10 or less columns from 50 plus column records. And what is the difference between the Hadoop and traditional RDBMS? This is very important for us to know. So when it comes to data types, in Hadoop processes semi-structured and unstructured data. In any RDBMS system, we have it can process only the structured data. It's capable of storing only structured data. Schema, we have schema on read, and in RDBMS we have schema on write. Best fit for applications, in Hadoop we have it can be best fit for data discovery and massive storage processing of unstructured data, and the RDBMS is best suited for OLTP, any complex ACID transactions. And speed, when it comes to Hadoop, writes are fast and in RDBMS reads are fast. So this is again another differentiation that we have based on the data size. The RDBMS basically stores it in gigabytes range of data, and Hadoop can manage somewhere on petabytes and hexabytes of data. And access interactive and batch, in Hadoop we have the access through batch. Updates, read, write many times. Write once, read many times is what we normally do in Hadoop. And in structured, we have static schema in RDBMS, and we have dynamic schema in Hadoop. Integrity, high asset, and here we have the low integrity in Hadoop. Scaling, non-linear scaling is what normally we have it in RDBMS, but Hadoop we have the linear scaling. So what is a block and a block scanner in HDFS? So a block, the minimum amount of data that can be read or written in generally referred to as a block in HDFS. The default size of a block in HDFS is 64 MB. Block scanner. Block scanner tracks the list of blocks present on a data node and verifies them to find any kind of checksum errors. Block scanners use a throttling mechanism to reserve disk bandwidth on the data node. Explain the difference between a name node, backup node, and checkpoint name node. So name node basically is at the heart of the HDFS file system, which manages the metadata, that is the data of the file is not stored on the name node, but rather it has the directory tree of all the file present in the HDFS file. So I'm going to discuss in detail about this I'll continue from this question in the next session. Thanks for watching this video. Yeah, do not forget to subscribe to our channel www.youtube.com/Softech. And if at all, if